Hi there, this is Gary Patterson. I'm the Municipal Market Manager for DSI Dynamatic, and I'm here with Eric.
Hi, I'm Eric Shebold with Environmental Sales. I'm a manufacturer's representative for water and wastewater process equipment. I've been doing this for 37 years now, and happy to be representing Dynamatic.
Just remind folks that you're our guy in the state of Michigan, and we're darn proud of you. So let's talk a minute about what kind of challenges do you face when you're talking to people about eddy current drives? Anybody bring up any consistent objections?
Well, I think one of them is a lot of the engineers have been misled on the energy efficiency story, and we're starting to overcome that a little bit. And
well, that is a common misconception. We run into that a lot, but there is a small kernel of truth in the matter.
Yes and no. I mean, if you want to pick a very select point here and there, I suppose, but I think overall, the energy efficiency is probably about the same. I don't think you're going to see great savings using a VFD compared to an eddy current drive or vice versa.
Well, I think you're probably right. Actually, the misconception comes when people start looking at the drive percent efficiency as a function of reduced speed, and there is a genuine decline in the efficiency as you go to lower speeds. But remember, at lower speeds, the centrifugal pump loads, which is by far our most common application in water and wastewater, the centrifugal pump load is greatly diminished, and so that lower efficiency applies to a much reduced load.
Well, that's right. And so, I think for years, these engineers have been shown graphs that misrepresent the efficiency curves and the energy consumption curves of pumps and motors.
Well, now you hit on it. It's the energy consumption that really matters. The actual degree of efficiency is a misleading presentation of the facts. But when you get right down to it, the actual power consumption over the useful range of speeds for centrifugal pumps in these applications is almost identical when you take it piece by piece. There's a few places where the eddy current drive will be lower efficiency or higher loss, if you wish, and there will be other places where the eddy current drive strongly outperforms the variable frequency drive in the upper end of the speed range, where the power is the greatest and where the better efficiency really matters.
Well, that's true. And the other thing that's hard for a lot of these engineers to understand, because many of them have only been in the business for 20 years or so, is they really don't have much experience with the eddy current drives. And when you tell them that, there are eddy current drives out there in our state that are 50, 60 years old or more, I think it surprises them quite a bit. And I think that tends to open their eyes a little bit.
You're right. We find that is usually a very impressive statistic, and it's not especially uncommon. We find on a regular basis, we find units in service since the 1970s. And lately I've come into a couple of applications that date back to even 1960 that are still in operation. Now consider the amount of capital expenditure that's been saved over that many years compared to relatively small differentials in energy consumption, if they even do favor the VFDs. If you actually are saving a few bucks a year with a VFD, you can't possibly compare that to the great deal of savings associated with not having to replace that equipment every 10 or 12 years, like is common with VFD.
Well, that's absolutely correct. There are, plants in Michigan that have, put the VFDs in, but they wind up replacing them every, 7 to 12 years. I think the old men in the game, or I use that relatively, meaning the older variable frequency drives are 20 years old. But again, that's only a half to a third the life of an eddy current drive.
Well, that's right. And I think that's one of those things that's playing in our favor with that project we're working on right now, which we probably shouldn't mention by name at the moment. But there's a project that they've had motors and pumps in service in that station since the 1930s or maybe earlier. And
that's right.
And they're not even going to replace those. They're going to refurbish that equipment and retrofit it with eddy current drives for what will probably be another 50 years of service.
Absolutely. And, the other thing that a lot of the engineers don't get too involved in is how challenging is it to maintain variable frequency drives versus eddy current drives over the years. I mean, to really maintain a variable frequency drive, you need somebody who's a skilled electrician and skilled in diagnostics. And I don't think that's as much the case with eddy current drives.
Well, that's right. If you buy a variable frequency drive, especially a high horsepower, high voltage unit, you're quite dependent on some kind of a pro from Dover to come and help you fix that thing if it's giving you some trouble. Well, Eric, I think we want to thank the folks watching for putting up with us this amount of time. And I think maybe we'll get together in another couple of weeks and discuss another topic. If we become an internet sensation, like I hope we will.
Well, I hope we do, and it'll all be to your credit.
All right. Thanks again, Eric.
All right, Gary. Thank you.
See ya.